located here in the northern part of the coast, in the western region of Abu Dhabi, some distance inland from sites we'll be hearing about shortly at Marawa Island, and essentially consists of a large scatter of broken bones lying in the desert. The site was found in 2008 in the course of work on the work on the pipeline, not least when a bulldozer in search of raw material for a gas road actually drove into the site and disturbed a large amount of material. Initial survey showed that the site consists basically of material spread around a shallow depression surrounded by dunes, so it's on a land surface over which dunes are now encroaching. And we've been able to generate useful elevation models that show this, I think, very, very clearly here. And voila. And mapping was the first necessity. How much and how extensive are these clusters of animal bones? And so for the first few investigations, all the focus was very much on mapping what was on the surface and simply trying to understand the extent of this particular and rather unusual site. Essentially, what we find on the ground is a whole series of clusters of bones lying at the modern surface in the loose blown sand. Bones of camels, often articulated, appearing as does this one, for example, or this rather fine example here. And in total, 111 of these clusters have been recorded to date. Now that's a lot of camel bones lying out in the desert, and it obviously raises a whole series of important questions. And so to structure this talk, these are the questions we're going to try to deal with. Firstly, how did the site form? What are all these bones doing here? Why are all these camel skeletons lying around out in the desert? Second, when did this happen? And is it a single event or repeated events? And what can we learn about the camels? Until we were able to undertake excavation there in 2015, there was complete uncertainty even about the first of those questions. How did the site form? Why are they here? It could have been natural, disease, drought, starvation, something bringing a whole herd of camels to a natural death, or it could have been human intervention. And so, in fact, that became one of the very first questions we tried to tackle. Is this archaeology, or is this a natural death assemblage of a very unusual kind? The upper levels, as you've seen from the two clusters already, consist mainly of bones in some degree of anatomical articulation. They are lying together as they would in the body of the live animal, even though they're often quite fragmented. And on this rather splendid photograph, I've dropped in red lines to indicate the front and back legs of one individual, and the yellow lines indicate the back leg of a second individual. You see, it's not always immediately obvious where the skeletons lie, but with a little examination of the bone fragments, we can often show that these surface bones, what were first encountered, are pretty much in anatomical position. This is quite important. Notice too, if I can get the laser to function, here, this is the backbone and the neck of one individual, very tightly curved, and that's been particularly characteristic of a number of these skeletons. It was something that was immediately obvious. That tells us something straight away. When a large animal, such as a camel, a horse, whatever, dies on the ground or lies dead on the ground in a hot climate, skin and ligaments shrink, and often the neck curves back, the head curves back with it, and produces a very characteristic body position. The two that you see on the left of this image are both camel road deaths, a local one at the top and one from Australia at the bottom. And the body position of that lower one matches almost perfectly one of these dead camels that we have at the site at Baynunah. So, for a start then, we're dealing with animals that have died perhaps unsurprisingly, or lain dead at any rate, on a surface in a hot climate. This isn't something that's been buried and subsequently exposed by erosion. We've at least got that little bit of information. In 2015 and 2016, we've undertaken a degree of excavation of a couple of these clusters to try and understand more thoroughly what's going on. This particular one answered a number of key questions. Here we've removed the upper level, the most obvious superficial bones, and exposed the rib cage of two individuals that are lying together. And you can see, I think, on this, in this area, some reddening of the sand. And one of the team very astutely spotted this and said, "Ooh, I wonder if that could be the remnants of blood." Not the colour of blood itself, but the colour of the oxidized iron derived from heavy bleeding in the region of the thorax. And so it was no great surprise, but I must say a huge pleasure, when those ribs yielded a very fine projectile point, very characteristic local type, not unlike indeed some of the ones that Sophie Murray has just shown us, embedded in the rib cage of that particular individual, which really confirmed what we've been beginning to suspect. This is not a natural death site, this is a kill site. People killed these camels. They were there for that reason. Further excavation then, in this same cluster, has shown us that we have, in fact, a rather more complex picture. It's not just one layer of dead camels out on the surface, but there are other patches of bones that are not complete skeletons. They are groups of bones that belong together but are not whole animals. The red lines here, for example, here show a forelimb, front leg, of which the main bones are all in articulation, but they are separate from the whole of the rest of that camel. And in fact, there's another doing very much the same thing here as well. So there is some disarticulation of carcasses. They're not necessarily entire. And then at a slightly deeper level, there is bone, some of which I've picked out here and there. Is that the right one? Nope. I'll show you on the next slide, excuse me. Too many pictures of a trench here. At a slightly deeper level, as shown in these grey boxes, we have bones that are sitting in a very hard gypsum-impregnated and hydrite-impregnated silt, bones that are completely separate and often broken in antiquity. So as we got into these clusters, they became more complex and potentially, therefore, more informative. And what they seem to show us is that we're dealing with three distinctly different deposition events. The lowest of these, the first, the earliest, represented by these scattered, isolated pieces of bone dispersed amongst what was originally probably rather soft, wet silt, which has since hardened with the gypsum, but completely dispersed and disarticulated. A subsequent phase of deposition of partly dismembered carcasses, whole legs, stretches of backbone, but not complete animals. And then overlying that, this phase of more or less complete articulated carcasses that have then lain on a dry surface. So we have a sequence of events, and the question that immediately raises, of course, is whether that's three events over maybe 3 years or 3 centuries or longer. A suspicion, of course, that they are not too far apart in time because the dispersal of these scattered pieces may well have been caused by the later activity on the site, mixing and churning and moving material around. So how long does this represent? And having recovered a good sample of these camels, what more can we learn about them? Just to mention here before I hand over that the conservators working in this team, Karine Debut and Sonia O'Connor, have done a quite outstanding job in recovering a substantial sample of what is actually a very important assemblage of wild dromedary camel. Quite apart from the site itself, the specimens are of considerable importance as well. What have we learned from them? I will hand over to Marjan Mashkour at this point to take you through the answers to that question.
Excuse me. So, good afternoon. I will continue the talk by showing again this same slide with the questions, just to remind you the questions. So, thank you. So the question was if this was a single event or multiple events. Of course, what we immediately did, and in a large scale, from 2008, when Mark and myself began the excavation, was to take up bones and teeth and begin dating on these specimens. So the dates that you are seeing here, basically there are 3 lots of dates. The first one's beginning with a K-I, here maybe, I don't see it very well from here, but there are some of them that are the initial dates that we had. And then in 2014, we began to sample massively, and we have taken all these teeth that have been dated by Antoine Zazot in the National History Museum. They were, part of the work was done there and then measured in Belfast. They are done on apatite, on the inorganic part of the teeth. And the first initial dates that we made were made on collagen. Very little collagen was still preserved. And we have here dates that are made by Beta, but this is on the trench that I will show you later. So this is telling the formation of the site of the lake, and the other dates are talking about the camels. And as you can see, they are very consistent dates, a set of 27 dates that 23 are very, very consistent, and they show that these events happened in 500 years between 4,500 BC to 3,900 BC, and also indicates that these 3 supposed depositions were made in a very short time. So we have the hypothesis, looking at these dates, that actually the earliest dates were here and the latest dates were here. We are still sticking to this hypothesis. We have still to date several other samples because some of the parts of the sites is not dated, so we don't know exactly how this is organized, but we still stick to this hypothesis, and also because we have other evidences that can take us to this to stick to this hypothesis. This is a work that has been done by Ashburton and Adrian Parker. This is the trench in the center of the site. They have made this stratigraphic, analyzed this stratigraphic sequence. And what we are seeing here is very interesting, is that we have in the unit 1 to 3, we have this initial phase that shows initial deposition that is showing the very arid event. And here, at this point, we have the beginning of a change, climatic change, and the unit 4-5 composition shows the increased moisture and pluvial conditions. Then aeolian deposition, wind and sand, and then again increased moisture and pluvial conditions. And at the end, we have again this aridity event. So multiple climatic changes during this time. But of course, we cannot precisely date all these, and we have some problems for dating this, and we have made some OSL dates. We are still thinking about this. So anyhow, just to tell you that we can stick to this hypothesis of 3 different times in the formation and in the use of this site. So again, back to this same questions. So now, what can we learn about these camels? So, of course, we have done many analyses. Here we are talking about normal classical archaeozoological analysis that we could do. And one of the elements that is very important in the animal body are the teeth that give a lot of information, and namely the information on the age of the animals. So we are using the tooth wear to indicate the age of the animals, and we have done some measurements, and we can see that actually we have old animals, many old animals, and some young animals. As you can see here, these are teeth of young, immature individuals, and here they are worn teeth. So we have both type of animals. It's not a selected kill-off, as maybe in domestic herds. This is showing a natural herd with youngs and old animals. And also another indication we can have from the camels, because there is a big sexual dimorphism in camels. The females and males can be easily distinguished in the skeleton. And one of the ways to distinguish it are the canines, the presence of canines that you can see here. And so, again, we have a lot of males in this herd that have been killed by the prehistoric communities. And finally, what gives us a lot of information is size and measurements that we take in the site. So here I have shown in the bottom of the graph, these are the camel site measurements that we have made on our specimens in Baynunah. And I have compared this to other camel assemblages, big assemblages that we have in UAE. And I have ordered this chronologically. So here you have Bronze Age sites, and the largest assemblage we have is Isotopes. And then we have Tel Abrak, Bronze and Iron Age, and Muela. And just I wanted to show you also to point at Hans Peter's discovery about the domestication of camels, that we can very clearly see in Tel Abrak, Bronze Age and Iron Age, that the shift of the size towards smaller animals. And just to come back here to our camel site, although they are smaller than the other three wild animals, but still we can put them in the wild animals and wild camels. So for sure we are facing wild camels in Baynunah. And finally, this is an ongoing research that I'm doing. We wanted also to have more indication on the environment from using other proxies, and also the way animals were living and moving. So one of the methods that is much used now are the stable isotope analysis. And just to show for those who maybe do not know the function of these stable isotopes, the oxygen isotopes are originating from ingested water and give you an indication about the temperature, basically, and the elevation. The carbon gives you indication about the diet of the animal, the herbs, the vegetation, and the type of the vegetation, if there is C3 plants like trees, or C4 plants like succulent herbs or grass. And the strontium, which is also very interesting, which gives you basically the geological substract. So it means if you mix these three isotopes, you can have an indication on the diet of the animal, on the temperatures, and also if the animal has moved from one place to another. So this is as I said, it is a very pilot project I have begun, but I have tested these on 3 animals, on 3 specimens from cluster 79, 72, and 85. And you can immediately see that what I have pointed with a red arrow, cluster 72, this animal has not done the same as the other two animals. And there is differences in the three parameters that we are using, carbon, oxygen, and strontium. So using this also with the three different events, I think we could, at one point, maybe in 1 or 2 years, come to a better understanding of this site. And just to finish quickly, so we wanted also to put this discovery of Baynunah Camel site into a bigger picture. So we tried to survey around the Baynunah, and actually very close to the Baynunah Camel site, we found evidence of human activities, and we discovered arrowheads and lithic tools not very far from the site. So this is the Baynunah Camel project team, 2015-16, and the project continued in 2017, but many of us were not there, and it was just Mark Beach and another team who were there to make a 3D documentation of the site. And that's it. Thank you very much.